All right, 7.5 in your textbook here, Foundations of Math 10. We have been talking about solving systems of linear equations, and what we've done so far is we've solved graphically, so graphing two lines, finding the intersection point. We've also solved algebraically using the substitution method. That was the last class. Today we're going to talk about the elimination method, or the elimination strategy. And elimination, if you think about that word, elimination means to basically to get rid of something, right? If something is being eliminated, that means we are getting rid of it, or it is kind of not in the equation anymore. So we are going to eliminate a variable, okay? So we're going to focus on eliminating a variable today. I'm going to show you how that happens. Okay, this example here, the very first example, is not going to be an equation per se that we're going to deal with, but if I wanted to, let's say I had y minus 5 equals 12, okay? So this is just a side example, but if I wanted to isolate for y, if I want to get y all by itself, I would want to get rid of the minus 5 from this side, right? If I want to get rid of this negative 5, what I would do is I would eliminate it from the left side of the equation, okay? So that's elimination. So how would I do that, though? How would I get rid of it? I would add 5 to both sides. Very good. Okay? So in a sense, we've been doing some elimination already. And in this sort of, in this spirit of elimination, that's kind of what we're going to be looking to do. Except we're not going to be picking a random value to add to both sides of an equation. Instead, we are going to be adding the two equations in the system together. Okay, so we're going to be adding equations together, and we're going to try to eliminate one of the variable terms in doing that. So here's an example. Let's just say that I am given this as a system of equations. 2x plus y, you want to write this down, equals negative 7. And I'm also given negative x minus y equals 4. Okay. Now, if I'm given this, now this second equation looks a little funny, right? It's not in general form. It's not in y equals mx plus b or point slope or anything. But it's valid. It's valid, okay? But what I want you to notice, the reason why I wrote this example right here, is that if we add, first of all, if we add equations together, which you can do that, what you have to remember is that you add like terms together. So the x's are kind of, in the vertical column together. I've also put the y terms in the vertical column together. The equal signs are lined up, and so are the constants on the other side. So this is sort of a way you're going to want to rearrange your equations so that you have this. But it's already done for you. Now, when you add two equations together, you add like terms together. So in this case, I have 2x minus 1x is 1x, or just x, right? And so when you add equations, you can basically add it up just like you're doing numbers in grade 5, okay? What about positive 1y minus 1y? What do I get when I add those together? Okay, plus 1 minus 1 is 0. So really, it's like I'm adding 0y here. Okay? Now, I know that looks a little bit funny, but just wait for it. Put the equal sign in the column under the equals, okay? So you don't actually adding equal signs, just put the equal sign there. And then negative 7 plus 4 is negative 3? What we say? Okay, good. Now, if you look at this right here, this 0 term, okay, if you have 0 y's, how many y's do you actually have? None, right? It's really like they're not even there. So this is what we've done. We have eliminated the y term. So if I add those y terms together, I actually eliminate them. Just like over here, you see this? Minus 5 plus 5 is actually 0. So I have 0 on this side. See? So it's the same sort of thing. So in elimination strategy, and notice now that this is gone, what is this equation actually equal. It's x equals negative 3. And in the substitution strategy, do you remember how we tried to solve for one of the variables first? So this is just another way to solve for one of the variables first. So let's just kind of write this down. Let's just summarize what we've got here so far, okay? Just write some notes down here at the bottom. In the elimination strategy, what we do is we manipulate the equations, and in this case, they were already lined up and done for you, okay? This was just the last step that I showed you. I'm going to show you how to manipulate the equations, one or both of them, so that when we add them together, one of the variable terms equals 0. Just like in this case, the y term was a 0y. And that is really eliminating that variable term from the resulting equation. So in this elimination strategy, we were going to want to rearrange or manipulate the equations so that we eliminate one of the variable terms. After we've done eliminating one of the variables, you get this situation where you have x equals in this case. So then we do everything the same as the substitution, and you find the partner y value. So in this case, what I'm going to do is I'm going to plug negative 3 in for x to the first equation, where y still exists here, and I'm going to solve for y. So it's going to be negative 7, and that's a negative 6 over there, so it's going to be a plus 6 over here. So y equals negative 1. So the last part of this strategy is exactly the same as substitution. We get one variable, and then we substitute in to get the other. All right, so let's do another example here, right from scratch. It's maybe a little bit trickier. Okay, so here's an example. 3x minus 4y equals 7. And 5x minus 6y equals 8. So here's a system of linear equations, and what we want to do is manipulate one or both equations so that when added together, one of the variable terms equals 0. What you have to remember is the variable terms when added together will equal 0 when the coefficients, that's the numbers, okay, let's look at x here. When the numbers themselves are the exact same, but the signs are what? Opposite, right? So if we can manipulate these equations to make this coefficient and this coefficient the exact same number, but with opposite signs, that's when we can add them together to eliminate one of the variable terms. Now, the question then is, how do we manipulate? What do you mean, Mr. Maxwell? How do we manipulate? Well, what we can do is we can rearrange the terms so that we kind of line them up. So that's a good idea to do, as I've mentioned. So these are all lined up. But the other thing we can do is we can multiply or divide the equations or the coefficients of the equations. So we can express this as multiples. Now, if I wanted to get these two terms to be the same number but opposite signs, first of all, what's the number that I would try to make each one of these be? What's the easiest number that's the same? Okay, 15. 3 and 5 have 15 as a multiple, right? So that's easy. So if we made one of them negative 15 and one of them positive 15, then we would be able to use this elimination. So what we do is this. Oh, goodness. Why did I go all the way back there? I'm not sure. Computers. Okay. So I'm going to suggest one of the possible ways we could do that to eliminate the x term is we're going to multiply the top equation. Let's make this a negative 15. So what do I multiply 3 by to get negative 15? Negative 5. Very good. And what do I have to multiply 5 by to get positive 15? Positive 3. Okay? Now, that's going to help us. That's going to make the x terms to be the same number but opposite sign. But we have to remember that because this is an equation, we have to multiply every term on both sides of the equation by these numbers. All right? So the new equation becomes, I'm just going to write it over here, negative 15x this is going to be what? Negative 5 times negative 4 is positive 20y. And what's negative 5 times positive 7? Negative 35. Good. So your multiplication tables can be really handy to have. If you're good at those multiplication tables, this is going to go real quick for you. The second equation, what does it become? 3 times 5 is 15x. 3 times negative 6 is negative 18. So that's what the sign is, right? If it's negative 18, it's a minus 18. And 3 times 8 is positive 24, right? Right, y, thank you. And then equals 24. All right, so does that look, everybody understand what we're doing there so far? Okay. Now, the reason why we got this is because now when we add these equations together, add them up, the x term is going to be eliminated. You want to do that? All right, so let's do that. This is 0x, so I'm not even going to write it anymore. That's going to be gone. They're going to add up to 0. What about 20 plus negative 18, or same as 20 minus 18? That's going to be 2y. Good. And what about negative 35 plus 24? Negative 11. Everyone agree with that? Okay. And so when I solve for y, now here's an equation now that doesn't have an x term. It only has a y term. So I solve for y. Divide by 2. Divide by 2. I get y equals negative 5.5. So you can leave this as a fraction or you can write it as a decimal, 5.5. Right now it doesn't matter. So y equals negative 5.5. That's fine. Okay, so that's half. That's the first half. Now we got to do the second half, right? Which is what? Plug this y value into one of the original equations and solve for x. So now this is the same as substitution. So we'll go ahead and do that. I will just take the first and do the original equations because, it's always best to do the original equations. So 3x minus 4 times negative 5.5 equals 7. So that's 3x equals 7. Okay, now this is, well, let me show you one more step in between, I guess, so you can see what I'm doing. 3x and negative 4 times negative 5.5 is going to be what? Negative 4, or minus 4 times the negative 5.5 is going to be plus 22. Everyone see that? The minus and the minus multiplied equals 7. So 3x equals 7 minus 22 is negative 15. X is going to be equal to negative 5. Everyone see that? So your answer is going to be the point, negative 5 and negative 5.5. Or you can just simply write x equals negative 5 and y equals negative 5.5. And of course we can check different ways. We can plug both values into each equation and make sure that they both are true statements. You can graph these and check the intersection point, which probably will take a little bit longer. But you should perform some kind of check just to make sure that this is working out right. Okay, so you can circle your answer and we'll be done. So the question is, how did I know to multiply the top one by the negative and the bottom one by the positive? The fact is that it doesn't matter which one is positive, which one's negative. So I would have gotten the same answer if I multiplied by this positive 5 and this negative 3. The work would have looked a little different, but we would have gotten the same answers. So yeah, so that's a good question. It doesn't have to be one negative and one positive. It can be either. Okay, any other questions? Yep. No. You didn't have to do 5 and 3. No, I chose 5 and 3 because that was sort of the easiest, the smallest numbers to get a common multiple there. If you multiply this by 50 and this by 30, you could do that as well. But the only thing is that you're going to be dealing with huge numbers, and it might make things a little difficult later on. But yeah, no, anything that would get the common number, you could just simply multiply this number by the other one. Always. You could always do that. And that will give you a common multiple. So let's do another example. A couple other questions about this one. If you use a bigger number, then all this means is, so this one, if I would use 30 and 50, it probably would end up something like this, right? 30, you know what I mean? So you just have bigger numbers and you got to divide them. It would come out to the exact same number. Yeah. Yeah, same numbers. Okay, yeah, another question? No, very good. Awesome question. Can you only do it to the x term? No, you can do it to the y term as well. And as a matter of fact, what I'll do is I'll do the same question with eliminating the y term. How about that? So you can see. But yes, that's a very good question. It doesn't matter which variable you eliminate. Okay, let me set that up for you. So here's the same question, and I'm going to take your suggestion there, and let's eliminate the y term. Okay, so we look at the y terms, and we need the same number but opposite sign. Okay. So what's a common multiple between 4 and 6? 12. Okay, good. Yeah, you can do 12. If you multiplied 4 times 6 and you said 24, that would be okay too. But 12 is the lowest common multiple. So if I wanted to get a positive 12 and a negative 12 here, what would I have to multiply this equation by? What's one of the options? Sorry? Okay, I could multiply this one by 3. That would give me a negative 12y, right? Now I want a positive 12y here, so what number would I multiply this equation by? Negative 2. It has to be negative because we want this to end up to be positive. One's negative and one's positive. If you did a positive here, then this one would have to be negative. Yep. Okay, yes, that's a good point. You could make all the exact same numbers and then just subtract. But, okay, here's the big but, right? When you subtract, there is lots of opportunity to make a mistake when you subtract integers. So students make mistakes all the time, like 5 minus a negative 3. You know how many people say 2? Okay? So there's opportunities all over the place for mistakes when you subtract. So the question that you said, can we just have the same number, the same sign, and subtract? Yes, you can. You can do that. I don't suggest that. I always suggest adding, because adding, you make fewer mistakes when you add than when you subtract integers, okay? So that's the only reason, and of course this isn't true, and if you make that mistake, the whole question's wrong. So that's why I suggest doing opposite signs and then adding. Now you may see even in the book where they subtract. I just don't like that. I don't like subtracting because I've seen so many kids, make mistakes. But good point, and you guys are very quick today, and you're asking good questions and making good observations. I love it. So let's continue on here, though. These equations are going to look like this. So it's going to be 9x minus 12y equals 21, and negative 10x plus 12y equals negative 16. Okay, I'm just going to go a little bit quicker here to save some rest of the time. So 9 minus 10 is negative x. Negative 12 plus 12 that's gone. And 21 minus 16 is 5. So, again, negative x doesn't do us any good. We need positive x equals, so x equals negative 5. Is that agreed upon? Plug that negative 5 into one of the original equations. So I'm going to do 3 times negative 5 minus 4y equals 7. So that's negative 15 minus 4y equals 7. 4y equals 7 plus 15, 22. Y equals 2 over 11, or 1 over, 5.5? 1 over 11, or negative 5.5. Okay, so if you look at these answers, negative 5 and negative 5.5, they are the same. Yeah? Something. Okay, why did I do what, sir? No. Okay, the step that I didn't show here was, okay, from there, what we do is we have to divide by -4. Is that what you mean? Yeah. That's right. So I have to add 15 to both sides. Okay, I'll just back up there. Add 15 to both sides. So 7 plus 15 is 22. And then all I'm left with, because that's gone, all I'm left with is this -4y equals 22. Yeah. I didn't show every single step there, sorry. But, you know, there's things that I mentioned that I didn't actually write down. But that's, I think everything's on par here. So when we get to this point, then you divide by -4 and you get this for an answer. Okay? Okay, good. All right, you guys ready to do one on your own? All right. No? Too bad. Too bad. So sad. All right. Let me give you a little bit of a straightforward one here. So how about do this one? X minus 4y equals 1, and x minus 2y equals -1. So use an elimination strategy here to solve this system of equations. Okay? Just like we've done. Go ahead. All right, so if we had a chance to run through that, this is what I did. The x terms already had the same coefficient, so I just multiplied 1 by -1. Doesn't matter which one. I said 1 by -1. So I eliminated the x terms, found y, plugged y in, found x, did a little check at the bottom there to make sure that those fit with both equations, and then I was satisfied that this is the answer. Does this look right to you guys? Yeah? Question? Yes. Yeah. Yeah, that's right. You could, well, yeah, multiply. I would suggest multiplying the bottom one. If you're going to multiply by 2, multiply by -2, so that you could just add. But yes, you can eliminate the y term as well. I mean, if you have the same number in front of both x terms, it's probably an easy one to do. But yes, you should get the same answer. As long as you got these answers using an elimination strategy here, we're good. Okay? How are we doing? Yes? Okay, out of 5, show me. A 0, just a fist means is 0, I don't get it at all. A 5, all your fingers up, means this is really easy, I nailed it. I've got it. So how do you understand? Between 0 and 5, where are you? 1, 2, 5, 4. Okay, seeing a lot of fingers, that's really good. Okay, good. Let's do one more that might be on the trickier side. Okay, one more tricky question. All right, so this system of linear equations has fractions. As many of you have noted, you hate fractions. Well, too bad. We need to work with fractions. We shouldn't discriminate against fractions, okay? Okay, fractions are our friends. We need to be nice to fractions, okay? You like decimals better? Well, who cares? I don't know. Doesn't matter. Fractions, decimals, they both get a bad rap, actually. But listen, if a fraction or a decimal shows up to an integer party, they should be welcome, really. Just like any other. Well, maybe if the 0 shows up, you can maybe, talk about them. But fractions, okay. All right, so what are we going to do? What are we going to do here? We need to get. Now, you can get rid of the fractions if you really want. You hate them that much. You can get rid of them if you want. How would we get rid of the fractions in this equation? If I wanted to just eliminate all the fractions, first of all. Well, you wouldn't divide by anything, no, you're going to multiply by something. What? What did you say? What I'm trying to do, no, I'm trying to get rid of the fractions and the decimals. Yeah. I want whole numbers or integers. Yes, yeah, that's what I mean. So, yes, we could multiply by 6. If you really want to get rid of all the fractions, which is totally fine, multiply by 6. Why? Because 6 is a common multiple of the denominators here in this equation. Now, what would we multiply this one by to get rid of all the fractions? Well, if we multiply by 2, we'd still have a fraction over here. Well, 4 is our lowest common multiple. Think of multiples, right? 2, 4, 6, 8, 4. 4, 8, 12, 2. 2, 4, 6, 8. So 8 is a multiple, but 4 is the lowest. Okay, so what do these become? They become, do you know how to do 6 times 2/3? Oh boy. Really?
Oh, yeah.
Now, two things you could do. 6 times 2 is 12, divided by 3 is 4. The easiest thing to do is 6 over 3 reduces to what? 2 times 2 is 4. Well, no, listen, you don't need your calculator. Hey, put that calculator away. You don't need your calculator for this. No, don't do that. Don't do 2 divided by 3 times. Don't do that. Don't do that. Okay? Bad. 6 times 2 divided by 3. What is 6 times 1 half? Minus 3y. What's 6 times 4? 24. No fractions. Okay, what about this one? 4 times 1 over 2. 2x plus y equals, this is, look at this, 4 divided by 2 is 2 times 5 is 10. You've never seen that before? Really? You should have seen that in grade 9 last year.
Oh, yeah, because it's the one where you like.
Yeah, okay, yeah, I know. Okay, but that's the, guys, okay. I'm just going to pause the video here. Alright, so if we take it from here, how can I get, which one do you want to eliminate? We can eliminate x, yes. We can also eliminate y. It doesn't matter which one. Doesn't matter. You want to eliminate y? Okay. So we're going to multiply this one by 3. Right? And what's that going to become? 6x plus 3y equals 30.
Wait a second.
I got a negative 3y and a positive 3y. See that?
Oh, you just multiplied it to the bottom one by 3.
I just multiplied the bottom one by 3.
How do you know if it's went to the bottom one?
Well, look at, I multiplied the bottom one and got this. Do I have to multiply this by anything, or is this the arrangement that I want? See, this is what I want.
Yeah.
So then you don't have to do anything to the top. Sometimes you have to multiply both top and bottom. Sometimes you don't. So now you can simply just add these things up. What do you get? 10x. Y's are gone. 54. X equals 5.4 when you divide both sides by 10. Right? Now, you can use your calculator for this part if you want, plugging the x into this, whatever. You could also, if you're confident that you actually did this first step right, you could put this number into the equation that you have manipulated. If you're confident you did everything right, then you can put it into here, which might be easier. It doesn't matter. So what I'm saying is that you could use this equation as well. So 4 times 5.4 minus 3y equals 24. So what's 4 times 5.4? So you get this. What's 24 minus 21.6? 2.4 divided by negative 3. Y equals, okay, quiet. Negative 0.8. All right, so those are your two answers. You should check those answers. Make sure you got them right.